Unit 3A, Lesson 1. This lesson aligns with 3.3 and 5.7 in your textbooks. In this lesson, we're going to be working with equations and inequalities, focusing on solving linear and quadratic inequalities. First thing I want you to do is, on your own, compare and contrast equations and inequalities. So in your notes, write down some similarities between equations and inequalities, and also think about write down some differences between equations and inequalities. You can refer to our algebraic expressions for them, to the graphs, anything you can think of. Write down some similarities and differences. In this first example, I want you to write the linear inequality represented by the graph. So we're going to write this in slope-intercept form. Our related equation would be y equals mx plus b. The only difference we're going to have is, rather than having the equal sign, we'll have some sort of inequality symbol. So if we're going to be in slope-intercept form, we have to identify the slope and the y-intercept. Our y-intercept, we can see by the graph, is -2. And using 2 points that are easy to work with, 0, -2, and 1, 2, we can identify the slope. We'd go up 1, 2, 3, 4 over 1. So slope is 4, y-intercept is -2. So we know this has to be in the form y compared to 4x minus 2. Now we have to determine what inequality symbol would go here. Since the line is dotted, we know it cannot be equal to, so this is strictly going to be less than or greater than. And how we can determine that is pick a test point. We could pick the ordered pair 0, 0 because we know the origin is a point that's in our shaded region, which represents the solution to this inequality. So let's plug in that ordered pair 0, 0 into this inequality. So we would have 0 compared to 4 times 0 minus 2. And then if we simplify, we get 0 compared to 0 minus 2, -2. So determining whether this is greater than or less than, we know 0 is greater than -2, which means all of these symbols must be the same. So we get y is greater than 4x minus 2. That is the linear inequality that represents this graph. Another example, we want to write the linear inequality represented by this graph. So again, we're going to relate it to the slope-intercept form of the equation. We have to identify the slope and the y-intercept. We can see the y-intercept is 3. The slope, we have to use 2 points that are easy to work with. So 0, 3, and 4, -2. So I would go down 1, 2, 3, 4, 5 over 4. So my slope would be -5/4. So for our equation, our inequality, we have y compared to -5/4 times x plus 3. Just like last time, now we're going to pick a test point, plug that in, determine whether or not what inequality symbol we have to use. Okay, the test point we're going to use is going to be the origin. The only difference is this time the origin is not a part of the solution. So that just changes one thing at the end when we come up with our inequality symbol. This time our line is solid, which means it's either going to be greater than or equal to or less than or equal to in the end. So if we plug in 0, we have 0 compared to -5/4 times 0 plus 3. And if we simplify, we have 0 compared to a +3. Well, we know 0 is less than or equal to 3. But since that origin was not a part of the shaded region, which represents the solution, that means our inequality symbol is going to be the opposite of what we came up with. So we would have y is greater than or equal to -5/4 x plus 3. So this is the linear inequality that represents the graph of the shaded region. Now in the next examples, we're going to solve either the linear or quadratic inequality. So now we just need to isolate the variable. First, we would subtract 4 to the other side. We get -3x is less than or equal to -12. And then the last step, we would divide by -3. So we get x If we divide or multiply by a negative number, we have to flip the inequality symbol. So x is greater than or equal to positive 4. You only flip the inequality symbol if you have to multiply or divide by a negative number when solving the inequality. Now, if we were going to look at the graph of this solution, we would have a filled in circle at 4 because it's equal to, that point is included, and then all x values greater than or equal to 4. If your variable is on the left side, when you have it simplified, your inequality symbol will point in the direction that your solutions are going to go on the graph. So here, our arrow is pointing to the right, our solutions go to the right. That little trick only works if your variable is on the left side when you simplify your inequality. Now we're going to solve a quadratic inequality. If you look to the right, you can write what's called the related equation. All you do is change the inequality symbol to an equal sign. Some people find this easier to solve this quadratic as an equation first and then go back and replace your equal to sign with the inequality symbol. It's not necessary, but if you prefer to use that, then you may use that. So solving this quadratic, we can use any means we've talked about. Completing the square, you can use factoring, the quadratic formula. In this case, this actually factors nicely. We'll factor into x minus 4 times x plus 2. And then we get that is less than or equal to 0. Using the zero product property would set each of these factors equal to 0. So you would get x equals 4 and negative 2. To find the solution to a quadratic inequality requires a little more work than if this was a linear inequality. We have to take our 2 points, 4, negative 2, plot those on a number line. We fill those circles in because our inequality symbol was equal to, so those points are going to be included. Now we have to pick a point that is less than the smallest value, a point that is between those two values, and a point that is greater than. Okay, I could have used negative 4, I could have used a value of 1, I could have used a value of 6, it doesn't matter, as long as you have one that's less than, in between, and greater than. Now we have to check each of these points, plug them back into the original equation, and see if it gets us a result that is true. Okay, so if I plug negative 3 in, I have negative 3 minus 4, which is negative 7, and then negative 3 plus 2, which would be negative 1, less than or equal to 0. So I have negative 7 times negative 1, which is a positive 7, less than or equal to 0. We know that is not a true statement. So I'm just going to put a F there for false. Any solution less than negative 2 is not going to give us a true statement. Now we're going to do the same thing for 0. So if I plug 0 in, 0 minus 4, we have negative 4. 0 plus 2, we have a positive 2, less than or equal to 0. Negative 4 times 2, we get negative 8 is less than or equal to 0, which is a true statement, which means all of the points between negative 2 and 4 are going to be solutions to this region. Okay, that was a true statement. Now the last part, we have to check 5. So if we plug 5 in here, 5 minus 4, we get a value of 1. And then 5 plus 2, we get a value of 7 less than or equal to 0. So 7 less than or equal to 0, that is not a true statement, that is false. So we would not shade that region. So it turns out in this case, we're going to go from negative 2 to 4 for our solutions. Any point between negative 2 and 4, those points included, will satisfy this quadratic inequality. Another example, just like the last one, we're going to solve this quadratic inequality. Again, you could write the related equation and solve this quadratic equation first, but it's not necessary. So solving this, again, we could factor. This will factor into x minus 2 times x minus 4 greater than 0. Zero product property, set each of those factors equal to 0. We get x is equal to negative or a positive 2 and a positive 4. Just like last time, we're going to plot those points on a number line. This time, we're going to use open circles because those endpoints are not included. They're not equal to. So we could pick any points less than, between, and greater than our two values. So I pick 0 because it's easy to work with, 3 because it's easy to work with, and then 5. Now plug each of those in and simplify. 0 minus 2, we have negative 2, times 0 minus 4, negative 4, greater than 0. So we have negative 2 times negative 4, 8 greater than 0. We get a statement that is true. Now you can go in and plug each of these other values in. If you went in and plugged in 3, you would get a statement that is false. And if you plugged in 5, you would get a statement that is true. So if we're looking at our solutions, they would be everything less than 2 or greater than 4. Okay. So when you're solving these quadratic inequalities, something you'll start to notice are two endpoints. Our solutions are either going to be going in opposite directions, like this one, or the solutions are going to be between the two endpoints, like we had in the last example.